Tests of independence. Suppose that the analyst wants to see if there's a relation between company size and the nation of origin. For example, are domestic companies typically larger or smaller relative to their foreign counterparts? So do you see what's going on here, ladies and gentlemen? Is there a relationship between size and nation of origin? In other words, are these factors dependent or independent of each other? And you could see why an investment manager would be very interested in answering this question. So let's have a look at an index that's made up of 1,000 stocks, and these 1,000 stocks may be broken down as follows. So this would be a global index. You could see that it's got domestic stock and foreign stocks, and at the same time, this index includes small cap stocks and large cap stocks. So the grand total is 1,000, but let's see how these 1,000 stocks are categorized. So the way to read this is as follows. Of the 1,000 stocks, 80 are domestic small caps. Just very quickly, 150 are foreign small caps, 450 are domestic large caps, and 320 are foreign large caps. So that's how we extracted the 1,000 in total. Now this is called a contingency table. Now this data is in discrete format because all we're doing is we're counting the number of stocks that fit into each category. Therefore, this cannot be used directly to calculate correlation. So correlation, ladies and gentlemen, is between like variables such as returns. Like how are returns moving relative to each other? So that's how we calculate correlation from. But this information is not like that. So we're not seeing like how the returns between these groups are moving in line with each other. All we're doing is we're counting the number of stocks that fit into each category. So therefore, we need to use a non-parametric approach in order to see if there's a correlation between company size and nation of origin. So let's see what the procedure would be here. Step one, we want to calculate the probability for each category. So for example, the probability of domestic, in other words, out of the 1,000 stocks, the probability that you'll draw a domestic stock would be 53%. And how did we get that? Well, if you're looking at domestic, you can see in total there were 530 domestic stocks in that 1,000 stock index. And we do the same thing for all dimensions. So probability that you'll draw foreign stock. Well, let's see, out of a total of 1,000 stocks, 470 were foreign listed. So there's a 47% probability. And so what's the probability that you'll draw a small cap? Same thing, keep it simple. Out of the 1,000 stocks, how many are small cap? 230. So there's a 23% probability that the stock you draw from the index is small cap. And then finally, probability that we have a large cap. It's right here. So again, the way to read this, we have a total of 1,000 stocks. Of that, 770 are large cap. So that's a 77% probability. Step two, we're going to calculate the expected frequency for each cell, assuming that size and nationality are independent. Why is that important? Well, we've seen from a previous chapter that if two events are independent, we can find their joint probability simply by multiplying their respective probabilities together. So the first angle we're going to look at is domestic small caps. So you see we got these two events, small cap, so let's see, 23% probability, and domestic, that's a 53% probability, so there it is. And then you multiply it by 1,000 stocks in the index, you get 122. So how do we interpret the 122? Here's the way to interpret it. If company size and nation of origin were independent, out of 1,000 stocks, we would expect 122 to be small cap domestic listed. Let's do the other ones just so we get the hang of this. Well, what is the expected frequency? And let me just stop right there. we have actual values. So what we're doing here is we're comparing the actual number of observations with the expected number of observations if these parameters were independent, namely company size and nation of origin. All right, so again, start from the top. So if company size and nation of origin were independent, what percentage out of the, or how many stocks out of a total of 1,000 would be small cap foreign? Well, the probability that it's a small cap is 23%, it's right there. And the probability that it's foreign would be 47%, it's right there. So therefore, out of 1,000 stocks, we expect 108 to be small cap foreign listed. And just very quickly, ladies and gentlemen, we just got 2 more rows to go. How about large cap domestic? Well, the probability that it's a large cap is 77%, and that it's domestic listed is 53%. So there it is, times 1,000. So out of 1,000 stocks in the index, we expect 408 to be large cap domestic listed. And finally, large cap foreign. Well, let's see, the probability of large cap is 77%, and the probability that the stock is foreign listed is 47%. And so we multiply those probabilities together to get the joint probability for this scenario multiplied by the 1,000 stocks. So we expect 362 of the total 1,000 stocks to be large cap foreign listed. So of course, when you add up all these expected outcomes, it's mutually exhaustive. So therefore, it accounts for all 1,000 stocks. Now for step 3, for each cell, and what I mean by each cell is right there. So each of these are cells, right? Each of these are cells. So let's go and continue step 3. For each cell, square the difference between the actual and expected frequency, and then scale it by the expected frequency. So for small cap domestic, we saw 80 stocks. And if I could just go back again, here we are. Small cap domestic, there were 80. Yeah, but how many would you have expected in that cell if these 2 events were independent? Well, if they were independent, we would have expected 122 observations. So that's exactly what we do, minus 122. Then we square it, and then we scale it by dividing it by the expected number of observations for that cell. So we get 14.5. And we do this for every line item. And this time, I promise I'll just do just the second row because the process is the same for all of them. So small cap foreign, how many did we see in our table, like the actual number of observations? So there it is, small cap foreign. We saw 150 stocks fitting that profile. And what was the expected for small cap foreign? 108. So you put those 2 numbers together. So 150 minus 108. Square, and we divide it by the expected number for that cell. So then we get 16.43. So we do this for each cell, and then we add them all up, we get 40. So this would be our test statistic, or it'd be considered as the test statistic. So step 4, we do the hypothesis test. Now the null is that there is no relationship between company size and nationality. And let's assume a level of significance of 5%. And what that means is we're willing to give the null a 95% margin of error. Why are you giving the null a 95% margin of error? Because we're basing this test on a sample of observations, and samples can have errors. So that's why we want to build this margin of error around the null statement. Now, how do we do the test? In other words, how do we find out whether the sample came within that 95% range or outside of that 95% range? We use a chi distribution where the degrees of freedom is equal to column minus 1 and rows minus 1. And in our case, we had 2 columns and 2 rows. So that's where these numbers are coming from. So 2 minus 1 times 2 minus 1 is just equal to 1. So then we're going to go to the chi table, and we're going to look for degree of freedom 1. and the right tail area that's equal to 0.05. And here we are. We're looking at the chi table. And remember the degrees of freedom was 1. And the probability in the right tail area is 0.05. So when we triangulate the degrees of freedom with the right tail area, we get a critical value of 3.841. So that's where this number came in from. Then in step 5, that's where we have the decision rule, where we compare where the sample was relative to this critical value. And since the sample came outside of this critical value, which is really like a goalpost for the null, we would reject the null. In other words, what we were saying before is, with this 3.84, is that if the sample fell within 3.84 standard errors away from the null, we would still accept the null. But if the sample came 40 standard errors away from the null, then that's way too far from the null, and the conclusion is that the null can't be true because the sample just came in too far away from the null. So when you reject the null, what would the implication be? Well, let's see here. What did the null say? The null said that there is no relationship. So when you reject the null, what are you effectively saying? That there is a relationship. So that would be the conclusion. So based on this example that we just did, there is conclusive evidence that size and nationality are indeed related.